Good afternoon. Thank you for joining us today. My name is Burke Lokey. I'm the Bureau Chief for the Drainage Design Bureau at the DOT. My presentation today will provide an update on the status of the EDC change initiative at the DOT. I want to start out by describing what change is and why we're excited about the opportunities it presents. We'll also talk a little bit about why 2D hydraulic models are the default option for bridge design and what we have accomplished with them to date. So what is change? First of all, it's the acronym stands for Collaborative Hydraulics Advancing to the Next Generation Engineering. But essentially, it's one of several FHWA initiatives through the Everyday Counts program. And this particular one is to promote the use of 2D hydraulic modeling and bring the whole practice of engineering for bridge and drainage structure hydraulics into the 21st century using available technology. Of course, application of 2D hydraulic modeling has rapidly become the preferred analytical approach because it's so much more comprehensive a program, and it's does a better job on bridge scour, flood control design, bridge sizing, river restoration, and a whole host of other transportation-related hydraulic projects. This is because the interface of rivers and highways always presented a lot of design challenges, and typically these favor a 2D modeling approach. Concerns specific to highway facilities, things like accurate modeling of bridge waterways, roadway overtopping, longitudinal encroachments of roadways by channels, and determining variables for bridge scour calculations are better determined with 2D models. Obviously, since 2016, the use of 2D modeling has dramatically increased for transportation projects by agencies and their consultants. This increase is attributable to several factors, including the improved computational power of personal computers, which makes it feasible to use these computationally intense models on them. Also, the significant increased availability of high-quality digital ground elevation data, such as LiDAR. Improved numerical stability and the relative ease of use of these programs has improved greatly. And introduction of time-saving model development tools and graphical user interfaces, which occur primarily because 2D models are inherently geospatial. So hydraulic modeling, hydraulic engineering has evolved over many years, but essentially numerical models have been the primary method of performing bridge hydraulic analysis since the introduction of HEC2 in the late 60s. And then since the early 90s, as numerical models got more sophisticated, the number of projects using 2D models for transportation applications steadily increased, in part because there were long recognized limitations and inaccuracies of 1D models for complex hydraulic situations, which are often encountered at bridge waterways. In 2013, FHWA began using SRH2D and recommended its use for transportation hydraulic analysis. The surface water modeling system, pre-post processor software developed by FHWA, added SRH2D as a supported modeling program in 2013. And FHA subsequently partnered with Bureau of Reclamation to incorporate additional advanced hydraulic modeling elements into the program and supported the development of a custom graphical user interface by SMS for SMS by FHWA. So when we use 2D models, well, FHWA strongly recommends 2D models for all design scenarios of transportation projects involving complex hydraulics, as described in Hydraulic Design of Safe Bridges, which is HDS 7. Complex hydraulics include the following scenarios: areas with wide floodplains, highly variable floodplain roughness, highly sinuous channels, things like multiple embankment openings, moderate to high roadway skew, and roadway overtopping are all considered complex hydraulic situations. The HDS7 publication includes a table where it shows which scenarios are appropriate for 1D versus 2D modeling. Clearly, 2D modeling wins that battle. So what are the advantages of 2D models? Why do we think they're so much better? Well, 2D models compute the hydraulic parameters based on physical characteristics. And so this is a primary advantage of 2D models because it reduces model uncertainty by calculating most of the parameters that we have to make assumptions for when using 1D models. Other advantages including the fact that there are sophisticated development tools that are available that are related to the model being geospatial. So you can pull in aerial imagery, you can pull in various other forms of data, roadway data, you can pull in ground cover information, and you can use all of that to help build the model. Also, there's a lot more, because it's a grid-based geospatial model, you're not just computing variables at cross sections, but you're computing them at every cell within the domain. And so you get much more information. And in addition to that, you get the model is able to develop a whole raft of additional variables or parameters that you can't normally get with a 1D model. And finally, the visualization of results is a primary advantage of the 2D model because we can now plot the results across the model domain, and it can really make a difference. And I'll show you that in a little bit. The disadvantage, typically 2D models require a lot more terrain data, and that can have cost and schedule impacts. So we do have criteria for how much terrain data is needed. Boundary conditions are the inflow and outflow conditions for the model should have to be far enough away from the area or structure of interest that those boundaries don't affect the results of the model. Sometimes that can require that we have to push those boundaries as far as a half mile or more away from the bridge in particular that we're looking at. In addition, the domain width has to ensure that the entire flow of concern is contained within the model domain. Now, some of this is offset by the fact that we have an ability to acquire terrain data for large areas using drones, which has made this particular effort much less expensive and a lot quicker. In addition, there's another option is USGS LiDAR data, which is available for large parts of New Mexico now in the public domain, and more is on the way. In fact, I think UNM, the EDAC folks at UNM are hoping to have full coverage for New Mexico by 2024. Another disadvantage is that most most firms are unfamiliar with this and have some anxiety about how much complexity is involved in developing a 2D model. Well, the learning curve is steep, as we mentioned, but it's not any more so than for HEC-RAS 2D. And part of the issue that we've seen is that as we get more experience using the models, these are so powerful and have so much capability that we are continually finding brand new ways to use these models to get better answers. Our experience at the DOT with 2D modeling, we started in 2017. We were able to host a NHI, National Highway Institute training for both our staff and for our consultants to attend a 3-day training class. The class was held at the general office in October 2017. It was very well received. And since that time, we have aggressively moved towards acquiring 2D modeling experience and making 2D models the default for DOT bridges for both hydraulic design as well as scour analysis. In 2018, we were able to we started evaluating the 2D program while developing models for 5 separate bridges and then a large area drainage study. 3 of the bridges were done in-house, 2 were by consultants, as well as the area drainage study. During 2019, we pretty much completed the evaluation period and moved towards institutionalizing the use of 2D models at the DOT. In 2020, we subsequently were able to complete models for 12 other bridges, 5 by on-call consultants and 7 performed in-house. And we're now working with the Bridge Bureau to complete scour evaluations using SMS for 18 more bridges on live streams, including the San Juan and Animas, the Chama, and the Rio Grande. Our experience primarily has been that the learning curve is significant, but not terribly so, any more than learning HEC-RAS 2D, and especially if you can take the NHI class. What we've seen is that after engineers are able to complete 2 or 3 models, their ability to develop and refine models is significantly shortened to maybe a week or so. The big problem then is making sure you can acquire adequate terrain data and create the model mesh, which those 2 elements take the most time typically in a 2D model using SMS. We think that's an appropriate division since those are really critical steps in building a good model. Aspects that we are currently working on at the Bureau are learning how to integrate the 2D models into our civil 3D design process and exporting those model results back into the out to civil 3D. So what we want to be able to do is import CAD data for the roadway for either existing or proposed conditions, existing so we can see what the current conditions are, proposed so that we can evaluate alternatives. And then when we're done with the model, we can export those results back out to civil 3D. The intent there is to speed up and streamline that interface between modeling and design. And this is especially important This is especially important where there's any kind of grading in the channel that's required. And we do have that situation in quite a few of our bridges, particularly where we have dry arroyos that have tended to fill sediment up over time. Let's see. Here's an example of one of the output plots. And what we're looking at here is the water surface elevation as computed by the model, both in color shading as well as linear contours. And there's a lot of different ways to format that. In addition, you can see that the model is computed the inundation limits based on the terrain data. And the additional feature is you can see the flow vectors. These vectors represent both the velocity, magnitude, as well as the direction of flow. You can see in various areas where flow is relatively ineffective as reflected by very slow velocities, whereas through the bridge it increases dramatically. You can also see that we can determine the angle of attack on piers by using these flow vectors. So this is a case where the hydraulic model provides significant information to the bridge designers. In this case, we might recommend skewing the pier to match up with the flow line better. There are a lot of available resources. I'm not going to go through them, but one of the ones that's really helpful is the two-dimensional hydraulic modeling reference document that FHWA has published. There's also a hydraulic modeling user forum. And as I mentioned, the class that's available from the National Highway Institute. Also, Aquaveo has a lot of tutorials on their website. And you can actually download the program from the Aquaveo website. So a couple of questions might come to mind. First is, does an NMDOT require 2D modeling for bridge hydraulics and design? And the answer for that is yes. For all new projects, we typically are not going back and redoing bridges that have been recently completed in HECRAS and trying to redesign those. In addition, there are some rare exceptions that we may consider 1D models. The one that comes to mind is highway bridges over an irrigation canal, where the canal is pretty much a very simplified open channel flow problem, and that is an appropriate place to use a 1D model. Another question is, what model does the DOT prefer? And we do have a bias towards FHWA's SMS program. It's a preferred 2D model because it has actually been intentionally optimized to support transportation infrastructure design. And the SMS pre and post processor program has a lot of very specialized tools that can really facilitate the development of these models for transportation projects. We are okay with the use of HECRAS 2D in some cases, particularly where the bridge is not in danger of going into pressure flow. This is something that if you're considering using RAS 2D, you should be talking to the Drainage Bureau for a transportation bridge project. You need to talk to us at the Drainage Bureau and make a case for that, and we will consider it. That's the end of my presentation. Here is my contact info. I am happy to talk to anybody who wants to compare notes about use of 2D models. I do want to shout out to the FHWA for their foresight and long-range thinking and pushing the Everyday Counts program to enable innovation, and particularly for making this change initiative available and allowing us to participate in that. We think that has been extremely valuable, and I'm very appreciative to the folks at FHWA for working on that. With that, I hope you have a great day, and we will move on to the next presentation.